Hi everyone, my name is Mahesh Satyamuthi. I'm a co-founder of BespokeLabs.ai, where we focus on post-training and data curation. And today I'll be talking about evaluation and benchmarks for Gen-RecSys. A lot of this is based on my experience, of course, at my current role, as well as previously building recommendation systems with LLMs for YouTube at Google DeepMind. So this is the agenda. I'll introduce and the challenges, and then four main pillars that I want to cover are the offline evaluation, the benchmarks, evaluating for efficiency, and then the online and longitudinal evaluations, and then conclude the talk. So as the famous saying goes, you cannot manage what you don't measure, right? So what we want is to measure and evaluate a given recommender model. But the reality is a lot more complex because you are not evaluating just a recommender model, but you have a system in place. You may have some sort of a product where you have a bunch of recommender models working all of them working together to make the recommendations. So for example, you can have a bunch of retrieval models feeding to a ranking model, and then there is a twiddler and so on. And in each of these stages, there are already many challenges. Maybe even there is, like, for example, if you have ranking models, you need to consider the position bias. There are feedback loops in the data. Externalities affect how the recommendation system performs, and so on. And in all of this, now we are going to introduce multimodal models, LLMs, and all of these generative models, which is going to make the picture a lot more complex. So, having laid this groundwork, I want to kind of talk about the evolution of how recommendation models have been, changing over time. So earlier we used to have, or the traditional recommender models have these kind of well-known, well-defined quantities like probabilities, scores, ratings, and so on. Or embedding models, or sorry, retrieval models have embeddings. And now we are entering a territory where there are complex outputs such as explanations. A model may produce a paragraph of text, or as we saw before, it can even be like a image that it outputs. And also, soon enough, or maybe we are already in this regime, models are generating sort of like can create curated experiences, like entire videos generated. Here is an example of a personalized travel plan. So these are open-ended tasks. How do we evaluate these, right? And now we are also going away from these RMSE, MAE, all these well-known metrics. And in this new realm, what are the metrics to look at? So this is not well understood, right? And these models themselves are becoming a lot more bigger, and therefore they are computationally expensive. They also have like high latencies. So these things have material impact on not just the financial burden, but also the user impact. If, for example, recommendations take a long time to materialize, we go from pattern matching to uh, uh, we go from pattern matching to reasoning models, and from making mere suggestions to these models becoming more and more persuasive. Therefore, all sorts of societal harms that existed can be a lot more amplified right now. So, having laid out these challenges, I want to let's dive into the four pillars of evaluation. The first one is offline evaluation. So the way I think of offline evaluation is like you can look into you can have broadly two things, right? One is, okay, are these models, the new models, still doing traditional recommendation tasks? If so, we can fall back on those metrics. Or if they are producing more complex outputs, we have a bunch of methods that we will cover. So if there are if the models are being used to do things like CTR prediction, conversion rate prediction, or time spent prediction. So these are some of the conventional targets that people can identify, and they may also be able to. They may also identify other targets like, okay, what's the time spent in search page, because for example you want to minimize that. If your intuition is that if people spend more time on search, if you think that means recommendations are bad, then you want to reduce time spent on search. Anyway, these define the targets, and once you kind of understand the target, once you have defined it, you can kind of say, okay, these are the metrics that I'll use to measure and evaluate these targets, right? So an example would be RMSE for accuracy. Similarly, ranking metrics, retrieval metrics. These are well-known metrics. There is also the diversity, looking at like what's the diversity of recommendations, looking at the coverage of the corpus that was recommended, novelty, serendipity, and so on. But in the case where now the recommendation models are producing text, how do we do the evaluation? We can always use these metrics like blue score, rouge, and perplexity, but these were popular in many years back in the NLP era, but they don't really translate very well in the new regime. You can still use it, but they are not as helpful as newer methods like LLM as a judge, or even like just having humans look and grade the outputs. So for LLM as a judge, there are alpaca eval and empty bench and things like that. So here the idea is simple. You have some LLM or a prompt, or some sort of fine-tuned model or an agent that you have put together. Now you can use a larger model to kind of judge the output of this model. So in alpaca, well, what happens is you have a bunch of models that you want to kind of rank them for your use case, and therefore you get their responses and have a larger model to rank and get the win rate. And then in terms of like or you can the other thing you can do is, like, if you have a specific LLM and you're iterating on your prompt, or you are just iterating on the LLM, you can um, what you can do is you can have a reference response, say a golden response or a rubric, and then you can ask the model, ask a stronger model to kind of evaluate and give a score. These are some of the popular LLM as judge metrics. For example, faithfulness measures is the response grounded in the context or not. And then the answer relevance is like, is the answer relevant to the question? And Ragas is a popular library people use, especially for RAG based systems, and they have a bunch of metrics that they have defined. And of course, the win rate is from Alpaca. And finally, after all of this is done, we may want to kind of still fall back on human evaluation, where we have domain experts kind of grading the responses, or you hire agencies or contractors who kind of look at all of this and um, give a score. So that covers evaluations, and now let's look into the benchmarks. So, what's the goal of a benchmark? The benchmarks are supposed to help us iterate on model development, because they kind of standardize a data set, a task, and the metrics to look at. So, for LLMs, there are many benchmarks, as you may be aware, but for recommender systems, there are not as many. These are for traditional recommender models. These are some that we are familiar with, like Movie Lens, Amazon Reviews, Help Challenge, and so on. But already these are not as many as in the LLM regime, because these models, there is a subjective nature to recommendations, right? And as you introduce more complexity, like maybe there is dialogues and so on, the number of benchmarks here are kind of limited. So here are some that I know of, and I'm sure there are more coming up. So Readdl, Inspired, C4LM, Big Bench, kind of, because they have one recommender task, I think, in them. So here is kind of a comparison of Readdl and Inspired. They are for movie recommendations, where Readdl focuses a lot more on like the dialogue generation, sentiment analysis. Inspired focuses a lot more on the conversational aspect, and is the sociable social recommendations aspect. So again, taking a step back, like For the LLMs, for LLMs, there are many benchmarks, as you may know. Like for knowledge, there is MMLU. For math and reasoning, there is like AIME, GPQA, and all of those. And for hallucination, there is like AgriFact, HalluEval, and many of those benchmarks. And recently, there is the Helm benchmark is kind of interesting to look at, because they kind of talk about holistic evaluation of language models, not just like looking to few specific capabilities. So they define many scenarios and the metrics, and this is a holistic method of evaluating. Maybe we should have something similar for recommendation systems. And in general, I think for when we are thinking of benchmarks, I feel like we need to have more of these, like especially if you are considering multimodal benchmarks, or what about preferences, right? Like and maybe even things like how do we have benchmarks for red teaming, societal impact, and so on. So, something else that people don't normally think of but is important for these Gen-RecSys is evaluating for efficiency. There is the training aspect, inference aspect, and then also there is the energy consumption and various other factors, like okay, like what's the fault tolerance and so on. I'll not cover these two, but let's briefly look into training and inference efficiency. So, uh, in terms of training efficiency, you can think of computational cost, which is like how many hours of GPU, TPU, or CPU you're using, how much RAM you're using, storage, and so on. Or you kind of can put it all together into one financial cost, like these many dollars are spent for training, or what's the overall training time, right? Like is it 5 hours, 5 days, 50 days, and so on. And then also you can drill down a little bit more and look into things like flops utilization. So there is like hardware flops utilization, model flops utilization, and these are kind of saying how efficient the training is happening, right? Especially when you have large training runs, the efficiency matters a lot. And in terms of inference, there are a bunch of metrics. For example, how many GPUs are used, what's the dollar spent similarly as before, and what's the throughput, right? Like how many queries per second can I handle, how many users I can handle, what's the batch size, how many tokens per second, and also the latency, like the time to first token matters a lot, right? So if your throughput is high but then it takes like a minute for the first token to appear, that is going to churn the users. And now let's very briefly look into online and longitudinal evaluation. So where we are now is we have done sort of all the evaluation in an offline evaluations, and now we want to do two things, right? One is we will do a A/B testing to kind of understand how the users, that's kind of the ground truth, right? Like how the users are interacting with the system, how what is my actual target metrics going up. So there are some considerations, like you want to make sure you do at least for 7 days to take into account the weekend versus weekday effects. You have to consider seasonality and how users are sampled and so on. And after A/B testing is done, if the metrics look good, you deploy the model in production, and then you are in the realm of like, okay, how do I do a longitudinal evaluation? Like, what's the long-term impact? What's the business impact? So what the general methodology is here is you will have some sort of a holdback, which is the previous model, which this model is replacing, will still be running similar to a A/B test, as a holdback. And then after a few months, you can kind of revisit and see if your new model is actually improving the long term impact. Like maybe you can check if the daily active users are going up or not, and things like that. And another interesting perspective I want to bring to this table is, you want to understand who the stakeholder is, and they will have different concerns and they will have different perspectives on what the eval looks like. So far, what I've talked is kind of like in the realm of like data scientists and ML engineers, right? we if I'm a data scientist, I will look a lot more into like detail, like what's the offline metrics, online metrics, and all of these things. But if I'm an end user, I don't care about the AUC, right? Like all I am evaluating the system is like, is it making good recommendations? I'll be focusing on things like privacy. Is it personalized? Is the whole thing easy to use and so on? So, and now also, if the business owners and product managers, what they will be focusing on is like, okay, um, for them the AUC may not matter much. For them, they are like, okay, looking at long-term user retention, the business metrics, cost efficiency, competitive advantage, and so on. And lastly, uh, the government, what and civic organizations, what they will be if they are the stakeholders, they what they want to focus on is like, what's the societal impact? Is there transparency, fairness issues, safety and ethical implications, and so on. And with that, I, I can conclude this talk by saying that evaluation is very critical for improving the system. As I said, you cannot manage what you cannot measure. And but evaluation is extremely challenging due to the fact that the tasks are open-ended, the outputs are complex, and there are many systems that work together in a compound system. At the end of the day, we also need to systematically not just look into all these components, but we need better benchmarks which helps us iterate on the algorithms and the models themselves. And also something that we shouldn't ignore is the efficiency concern, right? These systems are really expensive to maintain, train, and like they have also environmental impact. And but having said all of that, there is like a lot of opportunity to do interesting research here. As an example, maybe there is a RecSys specific LLM as a judge that we can train. People have been training models that are specifically for LLM as a judge. Why don't we do that for RecSys? Because maybe we have a few other rubrics to consider, right? Like personalization and so on. We also need to make sure we evaluate on societal impact and things like that. So with that, I'll conclude the talk. Thank you, everyone.